Hello, and welcome to this video on Agile. In this session, we'll talk about the practices in extreme programming. Let's get started. XP has 12 practices, and the interaction between them help achieve higher levels of productivity and quality. Although it is possible to create software by making use of only a few practices, the best way is to practice it in its entirety. We can broadly classify XP practices into coding practices, developer practices, and business practices. Okay, let's start with coding practices. Writing code is the most important aspect of XP, as most of the time and resources in a project are devoted to it. Therefore, it defines how the system behaves. Now, let's take a look at a couple of coding practices that are used to produce code which is easy to maintain and understand. First is coding and designing. This practice follows the values of flexibility and simplicity. Flexibility is the aim, and simplicity is the means to the end. Flexibility is required to adapt to the changing business needs, and simplicity to make the code easier to understand, test, maintain, and change. Adopting the XP approach of taking small and simple steps and using continuous feedback to keep on track makes it easier to identify and rectify mistakes. The simplicity approach also advises against adding features that might be used in the future, as unnecessary features can complicate the project. While flexibility is the essence of the approach, XP finds flexibility through simplicity. So how do you produce a simple code and design? A simple code and design requires creating maintainable code, testing it continuously, cleaning the code regularly, seeking the simplest solution to the problem or refactoring, collective code ownership, and good communication between the developer and the customer to identify necessary features. The next coding practice is refactoring. What is it all about? Refactoring is improving the design of the present code without changing how the code behaves. The aim of this practice is to improve the maintainability of existing code and make it simpler, more concise, and more flexible. It involves eliminating repetitive and redundant code, breaking methods and functions into smaller routines, clearly defining variable and method names, simplifying the code design, and making the code easier to understand and modify. Adopting XP means letting the design of the code emerge as the project grows. This could result in some serious pitfalls. Regular refactoring reduces lag and leads to the optimum design for the code. Refactoring supports simple design by improving it regularly, and disciplined coding helps create cleaner code. So, what are the things to be kept in mind for effective refactoring? Effective refactoring requires coding discipline, comprehensive testing, collective code ownership, and developing coding standards. Another practice is developing coding standards. Coding standards are conventions that are used to enable developers to communicate their ideas clearly through code. They are guidelines for effective code writing and are not rigid rules. A coding standard is used to avoid unfamiliar coding styles. It includes creating a style that is widely understood and has standardized nomenclature and guidelines. Coding standards support refactoring, pair programming, and collective code ownership, as the code follows the style of the team rather than that of an individual. Coding standards require pair programming, which is to ensure that all code follows the defined guidelines. It also requires developer teamwork, which involves letting go of personal coding styles and adopting a new coding style to encourage communication of shared values. In addition to these, reviews are required, which will help to ensure that the existing code reflects the agreed standards. The last practice in coding is to develop a common vocabulary. Why is this so important? Let's see. Everyone on the team should understand the concepts and terms used to describe the project. For this, it's necessary that they use a common vocabulary. A good vocabulary makes effective use of word pictures and is designed with simplicity in mind. The aim is to help customers and others involved in the project who are considered laymen understand the common vocabulary without any external input. A common vocabulary supports collective code ownership and constant customer interactions. Okay, now let's take a look at the second broad area in XP practices, developer practices. As a discipline of software development that follows a specific structure, XP guides teams to design software for specific functionalities without adding any functionality that may slow down the process. Hence, developers are required to keep the development course simple by making use of systematic and regular testing and design improvements. Let's discuss some practices that XP utilizes to minimize debugging and software failures. First is test-driven development. XP relies heavily on repetition of short development cycles for the process of software development. Test-driven development, or TDD, follows this trend. The TDD process can be broken down into 6 simple steps. Let's list them one by one. First, the developer writes a test that the existing code fails. Then he writes the code that passes the test. After that, he refactors the code. Now he has to automate the complete test and keep testing the code. Feature is done when all tests are passed. The last step is to clean up the code and repeat. Now that we know the process of TDD, let's learn the different types of tests that are conducted while practicing it. There are 2 tests, unit testing and acceptance testing. Unit tests check the behavior of the code, of both individual units of code and the program modules together, to determine whether they are fit for use. Acceptance tests are run from a business and customer point of view. These tests check the requested and implemented feature and determine whether these features match the business and the customer requirements. Adopting TDD provides continuous and almost immediate feedback. This can be used to create code of good quality and also reduce the need for last-minute debugging and code corrections. Next, under developer practices, is pair programming. Pair programming is a situation where 2 people work together on the same computer. It can substantially increase the productivity of the developers by improving the quality of code. A developer can choose to be a driver or navigator and switch roles too. The driver writes the code from a micro perspective, only thinking about the functionality of the code, while the navigator directs the driver from a macro perspective, keeping the entire project in mind, guiding the driver to create code that is in accordance with the team and project guideline. Usually, a pair is formed to work on a single task. When that task is done, it is dissolved and a new one is formed. This is done to encourage collective code ownership. Pair programming requires proper infrastructure to support it, and developer and management acceptance to adopt it. The next practice under developer practices is collective code ownership. So what is collective code ownership? Collective code ownership refers to the practice wherein all the developers working on the project treat the entire code as if it were their own, even though they may only write a part of it. The aim of the practice is to spread the responsibility of the code across the team, rather than place it on an individual. The advantage is that any developer has authority to make changes to any part of the code when necessary. No special permissions are required. As a practice, collective code ownership encourages adopting coding standards because programmers feel proud when their colleagues do not have to make changes to their section of the code. This encourages the practice of writing clean code. And the last practice under developer practices is continuous integration. As we know, integration means to incorporate into a larger unit. The practice of continuous integration follows a similar principle, and the aim of the practice is to reduce the impact on the overall software development when adding and modifying features. XP requires the creation of a code repository or a code base where the team maintains the source code for the project. The aim is to maintain an up-to-date code base. So, as a practice, all the developers update the code base at regular intervals, the minimum requirement being once a day. Because multiple developers can be working on a project at any given time, continuous integration is used to ensure that everyone is on the same page and that everyone is working on the updated code. Builds are done as frequently as possible to make certain that additions to the code base do not break the build process. And now we come to the third broad area of practices, which is business practices. Business practices are adopted to ensure the relevance of the product from both the management and the customer point of view. Because resources are limited, a clear set of practices needs to be defined to safeguard the project against failure. Let's discuss the practices. First is adding a customer. Adding a customer to the team creates a path for clear and speedy feedback. This continuous feedback warrants the desired results. Observing the project enables the customer to provide immediate feedback. This greatly reduces the amount of guessing and rework that may be required at a later stage. The customer provides the team with the business perspective and helps prioritize the features that need to be implemented in the project. The customer, as a part of the team, addresses business concerns accurately and directly ensuring that a knowledgeable person is available continuously to review the work, communicating changing business requirements, and making decisions regarding software features when necessary. The next business practice is regular release. XP requires the system to be built in short iterations to demonstrate value to the customer. Because each increment is time-boxed, generally ranging from 1 to 4 weeks, the functionalities that can be developed in this time frame are constrained. Once the code passes all the tests, that is, the unit as well as the acceptance tests, the code is ready for release. The short release cycle leads to rapid and precise feedback, which can, in turn, be used for scheduling and implementing the required changes in the next iteration. Regular releases add more credibility to the code as bugs can be identified at an early stage and rectified. And as the customer gets to view the concrete product, they can provide the market and business relevant feedback directly. Also, when the software is maintained in a releasable state, it represents the greatest value for the customer's investments. A third practice under business practice is the planning game. The planning process in XP is referred to as the planning game. It's a platform where the customer discusses user stories with the developer. This interaction is vital for product development from both business and technical perspectives. The customer defines the scope of the release, decides the order of delivery of user stories, and sets the date of release, while the developers estimate the time that each story will take, communicate technical impacts of implementing requirements, break down the stories into tasks, and allocate work among themselves. Apart from performing the above-stated functions, the customer and developers deal with the problems and questions arising during the development process. The planning game is further divided into 2 phases: release planning and iteration planning. The final practice to note here is maintaining a sustainable pace. The aim of this practice is to make sure that the team is fresh, so they can continue to work at an aggressive but sustainable pace. Though team velocity can be increased artificially by working longer hours, doing so can place unneeded stress on the team. Everyone has limited physical, mental, and creative energy, and the focus is to maintain the levels of energy and not deplete them all at once. As a team, the goal is to get the most completed, tested, and integrated during each iteration, but the effect of mistakes can cascade multifold. Trying to increase team velocity artificially can be counterproductive if the team becomes overworked and makes mistakes. Therefore, the challenge is to find the correct team velocity and to keep the working hours and lengths of iterations constant. And with that, we've come to the end of this session on practices in extreme programming. We learned that practices can be divided into 3 categories: coding practices, developer practices, and business practices. In the next module, we will discuss the release part of extreme programming. Until then, goodbye, and thanks for watching.